Okay, so this is going to be a build series for the Replicant Gen 1 drone from Eurosystems. And I'm going to talk about some of the features of the drone, some of the construction and design philosophy behind the drone. Talk about some of its features, like its modular battery system, its power button, our custom controller board, and what you can expect out of putting a kit like this together if you follow the build guide fully. So yeah, I'll just dive right in. I'll start with the frame itself. It's a 3D printed chassis. So the main chassis core itself is a carbon fiber nylon 3D print. I've just printed this main chassis on a Bamboo Lab P1S using Fiberon PA6CF. This top part is an SLA 3D print. And that's how we're able to get its geometry to be so smooth and clean, as well as having some of the detailed features. Some people have tried to print this on FDM. I think you're going to have varying levels of success. It might need a bit more cleanup, but hopefully people can print these on an FDM machine. If you purchase a kit, I am including this top cover in the kit, and I think most people will appreciate that sort of extra level of detail you get from that. Um, the nose cone, itself is another FDM print, and it's printed from a flexible TPE material. The reason we've gone for that flexible TPE is to basically just try and have a little bit more vibration isolation from the drone. Obviously, you get some vibration from or vibration generated by the props and the motors. Even when they're in good condition, you're still going to have some vibration generation that's going to travel down the arm and into the chassis core. And you in the better design drones do a better job of limiting how much of that vibration can get into the things like the flight controller and the nose cone. So we've opted to, a lot of drones have a TPE mount or some sort of silicon material between a rigid mounting structure and the physical camera body. But what we've opted to do is just create the nose cone with some good rigid geometry, but then fully print the entire nose cone out of TPE. And we've found that if you're using decent props and decent motors, that you'll get a very, very crisp and clean footage from the DJI 04 Pro system. So we've been pleased with that. It took a little while to sort of muck around with and get exactly how we wanted it to be, but it's worked out quite well. Another feature of the nose cone is it's actually got a GPS located in this top surface. So when you've got the nose cone off, it's flexible, so you can find a little pocket that you can slot the GPS into. We're using a Miko Air GPS to do that. It's the one thing about this build is that if you do decide to build it, you do have to stick very closely to the parts that are specified because of the tolerancing and details that are required to get things to fit. So with that, we'll move on to these other critical components. So obviously we're using a DJI 04 Pro Air unit. It's just an excellent device. It's got very good long range performance, and the camera quality is fantastic. So that's why I've chosen to go with that. The flight stack is an iFlight flight stack. I've picked that because it's very compact. The Borg Mini series is just a very high quality modern stack. The ESC is high power. It's not the most high performance processor in the Borg Mini flight controller, but it's not really necessary to have much more than that to get the results that we want to get out of this build. So that's why I've selected those. You can actually use an older model ESC. You can use the full size ESC as well, And I have used this ESC in other builds, but I've chosen to go. It's quite tight in the chassis, and so I'm recommending that people go with the Mini. It's also a little bit more modern and higher power, but you can use this will fit and has been designed to fit. Can be a little bit finicky to get in and do the soldering. I've done that on probably I would say 5 or 6 builds. You can do it. It's not impossible, but it's a little bit more tricky. So for that reason, I point people towards the Mini stack. So we've also got, because the drone has a power button, we've also got our own custom PCB. So this is just it's just a MOSFET power controller. So we've got a tiny little microcontroller on here that gives the button some behavior. So it's a press and hold to turn on, and it's about a 3-second hold or 2 and a bit second hold, and then there's another short press to turn the drone off. The reason we've gone for that is that when you attach the battery to the drone, it's a really positive engagement and it clicks into place. And so instead of having a requirement to pull the battery on and off like in a standard drone, we've opted to, you can just place the battery on the drone and then use the power button to turn the drone on and off. So that adds a little bit more complexity to the build, a little bit more cost. We've opted for some rather expensive components to make sure that it's a high current capable board. At one point, the drone had the ability to daisy chain batteries and would result in the potential for very high currents. So we've left it a little bit over engineered. It's using some really nice high quality MOSFETs and some and a nice discrete MOSFET driver as well. So it's not that's why it ends up being a little bit more of an expensive board. But there's a reason for that, and you'll see if you purchase a kit, you'll see some of the high quality precision components that we've actually used. This is the rail. So that's what that fits onto the bottom of the drone. That's what allows the battery to be connected. It's got a rail slot so that you can drop the battery in it, and it's very secure. One feature of having this rail system is that because the battery mass is about half the weight of the drone, it's 502 grams versus I think about 688 for the finished drone. It's quite a lot of mass to provide damping. So if you have some vibration in the frame, it's got to vibrate and move the battery to be able to then transfer into the flight controller, if that makes sense. So by having this really positive mounting system, that actually helps to reduce some of the amplitude out of the resonance that you get in the frame. So it's not just the sort of nice to have feature; it's also a pretty important thing to have for actually reducing vibration. So that basically covers most of the features of the drone, and so now we'll just get into putting it together.